back. We're doing notes 1.2. This is on density. In your book, it's pages 84 through 87. And in your study guide, that's going to be pages 40 through 42. All right, so before we get into density, we need to talk about a few definitions. So physical properties. First of all, physical properties are properties that are observed without changing the substance. So physical properties depend on the conditions at which they're measured. So say, for example, the state, whether it's solid, liquid, or gas. So some examples of physical properties are, for example, hydrogen peroxide is clear, colorless, and has a sharp odor. So we're talking about the appearance. It's clear, and colorless is the color. You really don't want to taste it because hydrogen peroxide is slightly poisonous. A lot of times if your dog eats chocolate, dogs can't eat chocolate because it's toxic for dogs. The vet will tell you to give a teaspoon of hydrogen peroxide every 15 minutes until your dog pukes. That's just to get the chocolate out of their system. So you don't want to drink hydrogen peroxide. That's not good for you. Odor, sharp odor. All right, so we're talking about physical properties. Also, the freezing point. So we're talking about melting points and boiling point. The freezing point of hydrogen peroxide is negative 0.43 degrees Celsius. And the boiling point is 150.2 degrees Celsius. All right, so we're going to see this a lot. This right here, right here, we're going to start seeing formulas written out. This is a chemical formula. It tells you have 2 atoms of hydrogen bonded with 2 atoms of oxygen. So H2O2 is the formula for hydrogen peroxide. Oh, I want to tell you this, by the way. So here's a joke for you. A man walks into a establishment and he tells the person at the counter, like it's a restaurant or whatever, and he tells the person at the counter that he's thirsty, and he says, well, what can I get for you? And he goes, well, how about an H2O? The guy says, all right, coming up. So he gives him a glass of water. H2O is water, and the man drinks it down. He's like, man, that was good. So the guy standing beside him was like, I think I'll have H2O too. So the man turns around and gives him a glass. He drinks it and he dies. Get it? H2O2. All right. Anyway, the freezing point of hydrogen peroxide are these. This is talking about the melting point and the boiling point. Those are still physical properties. Okay, and then the last thing here, we're talking about the density, which is what this video is really about. Solubility or specific heat. We're going to talk about those 2 concepts later in chemistry, but another physical property is the density of hydrogen peroxide is 1.450 grams per milliliter, and the specific heat is 2.619 joules per grams degree Celsius, and it is soluble in water. So what we're doing there is talking about different physical properties of hydrogen peroxide. So properties that are observed without changing the substance. So we can look at that and we can tell the color of hydrogen peroxide. After we look at it, it's still hydrogen peroxide. So we're not changing the substance. All right, another thing that test takers like to talk about are extensive and intensive properties. And you will be tested on this. I guarantee you it will be a test question. So if you've never heard of extensive or intensive properties of matter, I'm about to tell you what it is. So extensive properties, properties of a sample that do depend on the quantity that's present or how much you have. Intensive properties are properties of a substance that do not depend on the quantity or how much you have. So let's say, for example, we have the example I like to give on this is a green bowl of M&Ms. Okay. So let's talk about M&Ms. So I'm going to take M&Ms out of this bowl one at a time. Okay. Mass. So I take an M&M out. Let's just say the mass of this M&M is 1 gram. So I take the mass, 1 M&M out, the mass is 1 gram. If I take another M&M out, and put it here, now the mass is 2 grams. If I take another M&M out and put it here, the mass is now 3 grams. So is that property changing? Is mass changing every time I take an M&M out? Yes, it is. Okay, so it is an extensive property. Properties of a sample that do depend on the quantity that you have present. So mass is an extensive property. The more M&Ms I take out, the more mass it is. Same thing with volume. The more M&Ms I take out, the more volume it takes up, the more space it takes up. All right, so let's talk about examples of intensive property. So let's say I take an M&M out. Okay, what color is this M&M? It's green. All right, so let's take another M&M out. Now I have 2 M&Ms. What color are they now? Well, they're still green. I can take out 100 of these M&Ms and it's still going to be green. So that's an intensive property. It does not depend on how much you have. It's not going to change the color when I take a 4th M&M out. They're still going to be green. Okay, same with melting point. The melting point of this M&M is 98 degrees. The melting point of this M&M is 98 degrees. The melting point of this one is 98 degrees. The melting point of this one is 98. 4 M&Ms are still going to melt when you pop them in your mouth at 98 degrees. Oh, by the way, did you know that's why chocolate is so awesome? Is because the melting point of chocolate is the same as the melting point of the human body. Melting point of the human body. I'm sorry. I meant not the melting point of a body, but the body temperature. That's why we like chocolate so much, is because the melting point of chocolate is the same as the temperature of your body, 98 degrees. All right, so that's intensive and extensive properties. Let me put my M&Ms back. You don't want to leave M&Ms out on the counter. You probably don't want to take M&Ms out of a bowl and put them back either. So, but we can't eat these, so that's okay. All right, so let's talk about chemical properties now. We talked about physical properties. Now let's talk about chemical properties. Chemical properties, how a substance changes to other substances through a chemical change. All right, so corrosiveness is an example of a chemical property. Like we can talk about an iron nail, and we can talk about how corrosive this iron nail is when it changes into rust. Okay, so did you know that rust is really not the same thing as the iron nail? So if we leave an iron nail outside, it's going to rust, and it's going to keep rusting until the iron nail disappears. Then all you have is rust. So it's not something that attaches to the nail. It's the nail actually chemically changing into a different substance. Okay, so that's a chemical property. Or we can talk about gasoline, how combustible gasoline is. Now remember, when I ask, what does the word combustible mean? Lots and lots of students say exploding. It's really not exploding. Combustible means just to burn. But we think about gas being combustible. It's very, very combustible. So when you see gas combust, it's usually followed with an explosion. All right, so gasoline is combustible. Okay, that's the flammability of it. So that is a chemical property. The gasoline is actually changing into carbon dioxide and water. So it's changing its chemical properties. Okay, and toxicity. Sodium is just a plain metal sodium is highly reactive with water. So you don't want to put this in your mouth. Okay, you put it in your mouth and your head's going to explode. It's very reactive with water. But when we combine sodium with chlorine, by the way, chlorine gas is poisonous gas too. If you inhale chlorine gas, it will kill you. But we combine these two, sodium and chlorine, together, and it goes through a chemical reaction. They bond together, and it becomes what? Sodium chloride table salt. That's what the salt is that's on your table. So this is chemically changing. It's changing its properties to have new properties, and then it's no longer going to kill you. So those are chemical properties. All right, so we talk about elements and we talk about things going through physical and chemical changes. So an evidence of a chemical change taking place are bubbles, change in color, change in temperature, change in mass, or how much is there, and giving off light. So we can look at this, an example of this when we did our Alka-Seltzer rockets lab. So when we put the Alka-Seltzer down into the water that was in the canister, it started bubbling. So it was going through a chemical change. It was bubbling. And it was changing in mass. If we were to drop it down in the water and then let it sit there for, 10 seconds and take it out, the mass of the Alka-Seltzer is going to be less than what you started with because it's going through a chemical change. It's changing in mass. Some chemicals, when you mix them together, change in color. Some change in temperature, like the hot hands that you get to keep your hands warm in your gloves, like when you go camping or when you go hunting, or even if you're playing football in a really, really cold weather outside, they make these hot hands, things that you snap and to mix the chemicals together and it heats up. We're going to see chemicals like that when we study thermochemistry at the end of the year. They also make these cold packs that you can snap and squish together, these gel packs, and it gets really, really cold. So if you sprain your ankle, you need an ice pack or something, they have those portable ones that chemicals that they mix together and it gets really cold. Giving off light, an example of that would be like a light stick, or glow stick. At Halloween, or if you're going camping, you can snap these and mix the two chemicals together, and they start giving off light. So these are all evidences of a chemical change that's taking place. And of course, a new substance is created because it's going through a chemical change. A new substance is created. So we talked about a moment ago, H2O2 is hydrogen peroxide. And if you just take hydrogen peroxide and pour it in a beaker and just let it set, it's going to decompose, or what does that word mean? Break down. It's going to break down into water and oxygen. And it does this because the photons, the light, hits it and it makes it break down. So that's why when you go to the store and you buy hydrogen peroxide, it's always in a brown bottle, because the brown bottle helps shield the light from the liquid so that it doesn't break down into water and oxygen. Now, even though it breaks down into water, you still don't want to drink it because there could still be some hydrogen peroxide in there that hasn't broken down. All right, during physical changes, though, the substance only changes shape or form. So a physical change would be something like tearing paper. So you have a piece of paper, right? You tear it, it's still a piece of paper. It's still paper. It's just in a different shape or different forms. Okay, like boiling or freezing water. Well, if you boil water, okay, it's still going to be water. It's just in a different form now. It turns into a gas. And when you freeze water, it's still water. It doesn't change into something else. It's just solid water or ice. Okay. And breaking a stick in half, you have like a popsicle stick. You break the stick in half. Now you have two shorter pieces. It's still wood. Okay. It doesn't change into something else. It's still wood. It's just two different pieces. These are all physical changes. It does not change the chemical composition of the item. It's just a physical change. It's a different shape or form. All right, now all of this we've just talked to brings us to what we're going to talk about in our homework for this section is density. Okay, density. Density is an intensive property. All right, so let's go back and review. Intensive property. Intensive property does not depend on how much you have. It's still going to stay the same. Like green M&Ms, the color green is an intensive property. It doesn't matter how much you have. Okay? And it describes the compactness of a substance. So how tightly the atoms are packed in the substance. Okay? Substances have unique densities at a given physical condition like temperature and pressure. All right, so we talked about units in our section 1.1 on measurements. We talked about grams when we were talking about the metric system, and milliliters when we talked about the metric system. But the units for density are a combined unit. It's a combined unit. It's grams per milliliter. All right, so it's how many grams of a substance you have per, if it's a liquid, how much of the liquid that you have, grams per milliliter. Okay, and if we're talking about a solid, we're going to be talking about grams per cubic centimeters. Now, why cubic centimeters? Well, cubic centimeters because the volume of a solid, how do we get the volume of a solid? The volume of a solid is length, width, and height. Okay, so the volume is, there's 3 dimensions there, length, width, and height. So it's centimeters cubed. So it's cubic centimeters, so grams per cubic centimeters. Now, again, for volume, we can measure the volume in milliliters like we do in graduated cylinders, or in liters if it's a large volume. So here's another unit for density that's for large volumes, grams per liter. Okay, so we're going to look at a lot of these combinations of these units when we get to work in density problems. But let me give you the formula for density. Density is equal to mass divided by volume. So we're going to take the mass of a substance, we're going to divide it by the measured volume of that substance. That combined is going to give us the unit that we're looking for, either grams per milliliter, grams per liter, or grams per cubic centimeter. All right, and so we have this formula, mass is density is equal to mass over volume. Now I'm going to show you a little trick that you can do. Remember, I told you a trick. One of the requirements of doing chemistry is to know how to do rearranging simple algebra when you're rearranging a formula. So when you have 3 properties like this, density, mass, and volume, 3 variables, you can use this little triangle. And it helps you know how to rearrange better. Like, say, for example, if I'm looking for, so what you do is you draw the triangle and you draw a horizontal line here and a vertical line here. And you put density is equal to mass over, okay, see the line, mass is over volume. So density is equal to mass over volume. So what you do is you take your thumb, I'm going to use this, or your finger. I'm going to use this square here to represent your thumb or finger. So when you get this triangle set up, let's say I'm trying to calculate the density. I'm reading a problem and it says, what is the density of blah, 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 blah. Well, what you do is you take your finger or something and you cover up the variable that you're looking for, and it gives you the formula. So we see here mass is over the volume, and that's the formula for density, is mass over volume. Okay, so let's say we're working a problem and it says you have a stick and the density is this number, X, and your volume is this number, Y. What is the mass of the stick? Calculate the mass. Well, we can do that. If we have the density and the volume, if we have 2 of the 3 variables, then we can calculate what the third one is. It's like solving for X. So what we do is you're trying to solve for mass, so I'll put my finger or my thumb over mass. And if you have 2 variables that are next to each other with a line here, that means to multiply. So if we're looking for the mass, we're going to take our density, multiply it by our volume, and bingo, we have the mass. Okay, same thing with volume. If it says you have the density is X and you have the mass as Y, calculate the volume. Well, cover up the volume. And it tells you that the formula is mass divided by, or mass over density, mass divided by density. So you just plug those in and you're going to get the volume. Okay, simple, easy peasy. All right, so I'm going to teach you the first trick, this first acronym in solving problems. Chemistry is solving problems, problem after problem after problem. Okay, so if you will use this acronym to help you solve the problems, then it will make the problems a lot easier. And the acronym is GLUES. So G, what does G mean? Well, circle all of your givens. That's your given. So you read the problem, you're going to circle all of the data in the problem that are your givens. Okay, and those are the numbers that they give you. L, list the givens out, list them under the problem, and then label them with units, like is, mass. What is mass? Mass is grams. So we're going to take mass and we're going to label it as grams. Okay. Then you underline, that means underline what you're looking for. So the problem will say find the density, or find the mass, or find something else. All right. So you underline what you're looking for so you know what your final goal is. And then E, you want to set up your equation. Okay. So if this problem is that you're solving has some equation that is going along with it, like the density equation that we have here, the density is equal to mass over volume, go ahead and write down what your equation is. And then if you have to rearrange it so that you're solving for what you underlined. Then once you have your equation written down and rearranged, then you're going to substitute in the values that you were given and then solve the problem. It makes it really, really simple if you go through these steps. Okay, and it may seem simple and it may seem elementary, but if you go through these steps every single time, it's going to solve the problem for you. So a lot of students tell me, it's like, I just don't know where to get started. When I see these problems, I don't know where to start. Well, do this. Do glues in this order, and it will help you solve the problem. You'll know exactly what to do. Just don't overthink word problems. Just follow this format, and it will help you solve all of your problems. Okay, so we're going to work some problems in class. Just make sure you have these notes when you come to class, and then we'll get the homework, and then we'll start solving some problems together on the board. All right, if you like this video, or if you want to know when I do post videos on my YouTube channel, just hit the like and subscribe button down here at the bottom somewhere, and give me a thumbs up on this. Thanks. Bye.